All right, Auto 2, we're going to be talking about starting system diagnosis today. We're going to begin by looking at common problems that a starting system has. So the first one is a no crank problem where the crankshaft doesn't rotate, and we use the word crank to abbreviate for crankshaft. So when you go to that start or crank position, you've got no crank. Second scenario is a slow cranking condition where the crankshaft rotates slower than normal. And I just want to back up for a moment here and just say that when you have a no crank problem, the first thing you're thinking about, okay, what's the condition of the battery? Do I have battery power? Secondly, do I have lights on the dash? If I have lights on the dash, is the theft light flashing fast? So maybe I tripped the alarm. Is it in park or neutral, or do I have the clutch fully depressed, etc.? So those are some of the things that we're going to look at. Secondly, when we have a slow cranking condition, typically we're thinking we have a battery with a low state of charge. Obviously, the theft system is not compromised because it wouldn't crank at all. So if it's cranking at all, we're thinking, okay, either I have a battery with a low state of charge, or maybe I've got bad battery connections to the battery, or is it possible that I have high mechanical load in the engine because something's wrong in the engine? Okay. Our third scenario, if I can get it to come up here, is the solenoid's clicking. In other words, I go to the crank position and I hear a loud click, maybe once. And if you'll pause for a second, I have a starter here that I think I can make it do this. So it'll sound a little bit different in the engine than this one here, but the slow cranking condition will be like, or sorry, the clicking will just be one click, or sometimes we'll hear a rapid clicking. So usually when we get a solenoid click, just one, or a rapid clicking, it's usually a battery at the low state of charge that's able to throw the gear out, but maybe not be able to hold it there, so it goes back and forth. Remember, there's a pull-in and a hold-in coil. Maybe the pull-in coil has enough magnetism to pull it, but the hold-in coil can't hold it there. Okay, let's keep going. And it says caused by a battery with a low state of charge or poor connections, or possibly a starter's motor internal problem. Any other noises caused by an overrunning clutch or a gear that's chirping? Sometimes we have to replace the gear on a starter. Sometimes there's actually shims. You can shim some starters away from the engine to help take care of some of those noises. I'll pause this for a moment. And I did that long enough so you could see the teeth on this flywheel ring gear that are chewed up pretty bad. And there's another spot on here in addition to this tooth being gone there and that one being gone there. This thing's pretty rough. And so that will be caused by a problem on the starter gear or the flywheel, but in any case, it's wearing the flywheel out, and something needs to be solved in that scenario. Let's go forward here. So next, we want to check for these problems. We're going to first look at the battery and its conditions and cables. We're going to, if it has a fender-mounted relay, meaning it's a Ford, could this guy be a problem? These are a common source of failure. This is the same guy that I had up in the starting system fundamentals lecture. There's a fender-mounted relay. The copper contacts do wear. They're about 20 bucks at the parts store. We can look for issues inside the starter. We have a neutral safety switch here that might be misadjusted, etc. Let's keep going forward. Actually, the one thing you're not seeing in the picture is you're not seeing a PCM. So we're not seeing any correlation between, let's say, a vehicle key and its chip talking to the computer. So this is obviously an older school car picture. We want to do the headlight test, if you remember from Auto 1. And the headlight test gives us a quick way of deciding, is the battery the issue or is the battery not? Is the starter's problem or what? So we're going to turn on the headlights and try and start the engine. If we get no cranking and no headlights, we know we got a battery with a low state or no energy, or with a cable connection problem. If the headlights dim and we have slow cranking, usually we've got a battery with a low state of charge, poor connections, or maybe a starter with high internal load. What's supposed to happen when the engine cranks? What's supposed to happen is the headlights are supposed to dim slightly, and then the car cranks at normal speed and starts. The reason why the lights dim is because the voltage there's a couple of volts being consumed to push the current through the starting system, and that's dimming the headlights down, because when we're cranking, we're usually like 10 or 11 volts, and we'll do this on the car. And so the headlights are used to being up at least 12 volts, so they dim just a little bit. So we expect it to dim, but we don't expect slow cranking. The next scenario is if the headlights stay bright and we get no cranking. So if I go to the crank position, the headlights don't dim at all, I know that the starting system, for whatever reason, is not trying to pull power from the battery. So I know for sure that this is not a battery problem. This is a vehicle theft problem, or a park neutral safety switch, or a clutch safety switch problem, or a key problem that's not talking to the anti-theft transceiver. I know that this one, headlights dim with slow cranking, could be a battery problem. I know that no cranking with no headlights is most likely a battery connection problem. Okay, so you can see it's a healthy or a helpful tool to use when you're down there in the parking lot and the car won't start. Let's keep going. So we're going to check the battery. First, we're going to verify its condition. And when we say verify its condition, meaning we're going to make sure that we're full of electrolyte, which means that we have a meniscus, which is about 3/4 down in the cell from the top of the battery. We're going to make sure our battery cable connections on the posts and on the cables themselves are clean. We have a battery brush to do that. Next, we can do a load test, which is kind of like putting you on a treadmill and seeing how you do under load. We're going to test the battery at half its cold cranking amp output, which is on top of the battery. So if it's a 600 cold cranking amp battery, we're going to test it at 300 cold cranking amps. We're going to try and suck that out with our load tester for 15 seconds and make sure that, see that the voltage stays above 9.6 volts. We can do a starter current flow, starter current flow may exceed 200 amps. We know that, requiring high battery output. Okay, we understand that. So one of the first things we want to do is a starter current draw test. So this is going to measure the current that the starting system's pulling from the battery. We're going to connect both a voltmeter and an ammeter, or we have a tester that's going to show us both of those. And what we're going to do is we're going to disable the engine. The best way to do it is by taking the fuse out for the fuel pump. If we disconnect the coil primary supply, we can do that if it is easily accessible and it has one coil. If it's got 6 or 8 coils, we're not going to do that. If it's an old school car, we can ground the coil wire, but the best thing is to pull the electric fuel pump fuse. Okay? Then we're going to crank until the voltage stabilizes. And the question is, what do we expect to see? We'll get that here. So they're putting an ammeter with an inductive lead over one of the battery cables, and they're putting a voltmeter. We can do that, but we're typically going to use a tester that we hook up with one set of connections, and it has one meter to read both. And so what we're looking at is we're going to crank the engine, and we're going to note the voltage. The amperage will equal starter current draw amount. So this is just showing with a car that has a single coil and a distributor, we can short the coil to ground. And this is showing some test values for our tests. So let's say we have a vehicle that's, most 4 and 6 cylinder engines usually are going to draw about 125 to 175 amps. And this tells us, hey, is the cranking voltage okay? Is the cranking okay? Then the system's okay. And it gives us some scenarios that we could think about there. So I'm going to pause here. So here we are out at the car with an 01 Dodge Ram 1500, and we're going to do a headlight test for the starting system. So the camera's going to look at this. I'm going to turn on the headlights, and I'll pause for just a moment, and then I'll crank the car. What I want you to do is notice that the headlight dims, and I want you to listen to the cranking speed of the engine. Here we go. So first, headlights are on. I'm going to crank. Here we go. I'll go one more time. Okay, so in addition to in addition to you hearing, seeing that headlight cranking just fine, but in addition to that, what you also did was you heard the cranking speed. Sorry for making you dizzy. You heard the cranking speed, and the cranking speed was just fine. I'll pause here for a second. Okay, so what I've done here is I've printed the ProDemand engine performance wiring diagram for a 5.2 liter, and I noticed that right here is the fuel pump relay, and I followed this red-white wire, which is number 5 over here. And I'm sorry, it's not the clearest to see, but that means we need to go to the second page of the wiring diagram. So here I go like this, and I go to the second page, and there's the red-white wire right there. And it's going to go, and I'm going to try and illustrate it by taking my pen and just going red, white, it's going up here, it's going over here, and it's going here, and it's going to this 20 amp. Come on, focus, dude. It's going to that 20 amp number 3 fuse, and it tells me it's in the power distribution block, which is in the engine compartment. So I'm going to walk over here to the car, and again, sorry for making you dizzy. I'm going to open up this guy, and here's the power distribution box over by the battery over here, and I've got to squeeze these 2 clips and pull it up, and on the underside I've got some fuse and relay detail. So I know I've got a fuse 3 20 amp, probably one of these 2 right here, or it could be one of these 20 amps here. So I'm going to look in here, and it should be called a fuel pump fuse. So these 2 here are the horn fuse and a transmission fuse. So it's going to be one of these over here. And so I'm taking a look. The 20 amp are these sort of tan ones, or sorry, yeah, tan pink, I guess. I don't know what you want to call it. And I'm going to pull the 20 amp one that's for the fuel pump relay, or I might just be able to pull the fuel system relay, which is this guy right here. So we'll go ahead and pull this fuel system relay. That might just be a quicker way to do it, and I'll set that over here. But again, one of these 3, this says engine control, this one says stop lamp, and this one says right here, it says it's a 30. Somebody's put a 30 amp there, but it's supposed to be a 20 amp. In any case, we'll pull that fuel pump relay. Now what I'm going to do is I'm going to go ahead and crank the vehicle. So here I go, getting ready to crank the vehicle. We're going to set up the meter. First thing I do is always push in these meter leads, push here and push here to make sure they're all the way in. I'm going to pull the connectors off, and I'm going to put on the alligator leads. So I've got a black negative side here. This is a little alligator lead. It's also got what's called a bed of nails, so I can actually pierce through a wire if I need to. I'm going to do my best to make sure that you can see the voltage on the screen. I'll turn it to V for volts, which automatically configures for a 12 volt vehicle. And yes, you can read that screen. I'm going to go ahead and go black to negative, red to positive. Remember, if you hook up a voltmeter backwards, it just reads negative. It doesn't hurt anything. So this thing has a resting voltage of 12.31 volts. Okay, and what's going to happen is, and I'm going to try and secure it here a little better so that when I crank it, you can see what's happening. So I'm going to crank the vehicle with that fuel pump relay out, and what's going to happen is you're going to see it probably drop down to 10.5 or 11. It might start momentarily as the fuel runs out of the injectors. Let's give it a shot, see what happens. Here we go. So, as I said, it did fire for just a moment because there was still some fuel left in the ignition, in the fuel system, and it kind of went up, but it finally settled to about, I saw about 10.95 volts. So we would call that our cranking voltage. Anything between 10 and 12 is good, but usually it's going to be between 10 and 11. So 10.95 volts. So this thing was roughly 12 point, I guess, 3 when we first started. So it's using up about a volt and a half approximately, pushing the current through the starter motor in the system. So we would say our resting voltage at the moment is 12.28 volts. Our cranking voltage was 10.95. The cranking speed was totally normal. We don't see any problems with this starting system at all. And again, by going to ProDemand, go to Engine Performance, Wiring Diagram, find the fuel, either find the fuel pump or the fuel pump relay, and you can find the fuse or just pull the relay out. I'm going to go ahead and put that fuel pump relay right back in, and I'll put this cover back on, and we'll start it up and make sure it starts. And you're going to see that voltage go from resting to cranking to charging system voltage. Here we go. So now, probably the digital readout was too much for you to see the cranking voltage, but there's our charging system voltage at approximately 13.78 volts. So what I'm going to do now is we're going to perform what's known as a starter current draw test. And in order to do a starter current draw test, once again, I do have to pull that fuel pump relay out so I can disable the vehicle from cranking. And we're going to use this AVR, which is an amperage voltage tester. We're going to take what they call the internal 18-volt leads, these big, heavy red and black leads. We're going to go red to positive, black to negative. This is not a battery charger, and it's not a jumper pack, so it's totally safe to hook up red to positive, black to negative. You're not going to get a spark. You could potentially get a spark if somebody was over here cranking up the load. Let me move the camera so you can see it just a little bit better. So if somebody was cranking the load here knob, but you'll see this one's saying we've got 12.2 resting volts. This one says we have 12.54. You might ask the question, which one you're going to believe. This digital voltmeter is a lot more accurate than this in terms of voltage, but it's ballpark. Before we hook up what's called the amps connector, we got the heavy 18-volt leads attached to the battery. We're going to zero the amps. So I'm going to get this down to 0 right there. Okay, I've got it zeroed. It just fluctuates between 0 and 1. The instructions that hang off the machine right here are going to tell you everything that you need to know about how to hook this up. But simply, this inductive lead needs to go around one of the battery cables. In this case, there's actually 2 positive leads, 2 negative leads. Whichever one you go over, you've got to go around both of them. So I'll go over to the positive side, and whether it reads positive or negative, it does not matter at all. So again, we're at 12.1 resting on this machine, 12.45 over here. We're going to crank it. The tester will tell, the instructions will tell you to crank it for 15 seconds, but we're going to crank it until the voltage just stabilizes, okay? So again, we're going to listen to cranking speed and so on. But what's going to happen is you're going to be seeing the amperage right here that this starter motor and starting system are going to draw, and we're looking for this voltage to stabilize. It's going to stabilize, let's say, at 10.8 volts or whatever, and we're going to read the amperage. So here we go. So I think I saw from the cab, it was a little hard for me to see, about 10.4 volts and about 160 amps. I'll see if I can get in a little bit better position by pulling the camera closer, and we'll give it one more shot. So we'll just come really, really close, and we'll point that camera down. So you're going to be looking right here. Now notice the resting voltage is down from all that cranking. So here we go. Let's see what we get now this time. Okay, so I saw 10.4 volts at approximately 156 amps. That seems just great. It was stable. The voltage was stable at 10.4 volts, and the current draw was about 150 to 160 amps. That should tell you guys that the health of the battery is good because you can hear the cranking speed. The health of the starting system is good, etc. So that's a starter current draw cranking test. And if you think about it, we're loading the battery, and we're going ahead and seeing what the starter's drawing. So there we go. That's it for now.